Hi, this is Dr. Huang. In this video, I would like to show you how to do two-way repeated measure ANOVA or use SPSS software. So what is the two-way repeated measure ANOVA? It is often used in study where you have measure one dependent variable over two or more time points. This will be independent variable. In another word, is you have one dependent variable, you have two or more independent variables. Normally it's the time and the condition. The main purpose of two-way repeated measures of ANOVA is to understand if there is an interaction between the two factors, for example, time and the treatment. It can be more than one treatment. Here I would like to show you one example. There is a chemical called quinolinic acid. The quinolinic acid is an inflammation biomarker which is found an increase in the patients suffering Alzheimer's disease. This quinolinic acid is an indicator of brain inflammation. You can measure this in the bloodstream or in the brain cerebral spinal fluid. A neuroscientist wants to test if this particular molecule, quinolinic acid, it will reduce neurite outgrowth. Neurite is a neural projection for neural connectivity. Now you have two independent variables. One is the treatment. For this is going to be quinolinic acid, or no treatment is a control. It's two independent variables, treated, not treated. The dependent variable will be neurite growth. So neuron has a projection that grow whether this quinolinic acid will reduce the growth. The total duration is 24 hours. So the scientists measured the neurite growth at 0 hours, the baseline, 6 hours, 12 hours, 18 hours, and 24 hours. So this is typical two-way repeated measure of ANOVA. So I'm going to open a file to show you how to do it in SPSS. Now here's the file scientist has recorded. Actually it's come from my group. No treatment, you put a 10 micromolar quinolinic acid, and 25, 50, 100, 200, and 306. 1, 2, 3, 4, 5, 6 concentrations plus control is 0 for each one. So we have repeated 1, 2, 3, 4, 5, 6 times. So when you do the repeated measure ANOVA, surely this is a two-way because you have no treatment and you have treatment. Treatment can be various concentrations. This is a typical pharmacological study. You go to general linear model, say repeated measure. And here's the time. So, So we have 5 time points. These 5 time points are 0 hour, 6 hours, 12 hours, 18 hours, and 24 hours. Then you have groups. You have actually have a control group. Then you have other 6 treatment groups here. Then you check the option. You say I want to have a descriptive statistics, give it my basic some data, then post hoc analysis, and now we'll put a group, also the time. Then when I do the comparison, the compare main effects, I will use Boniferroni for this type of repeated measure. To look at the post hoc in terms of compare different groups, I will again use Boniferroni post hoc. I will do the plots. When I do the plots, the time I always go for the horizontal. I can see the time effects. Then I will put a group in the separate line. Say add, then say continue. Now we will do the report. Say OK. So when you do the report, as you can see here, I have 1, 2, 3, 4, 5 time points. I'm going to measure the cell neurite growth at 0, 6, 12, 18, and 24 hours. That's for the whole day, 24 hours. In terms of groups, I have 7 groups. This is the control group, which is zero quinolinic acid. I have low to high, from 25, 50, 100, and 200 and 300. I have 6 of them. So here is your descriptive analysis. Look, there's a lot of number here. Actually, gradually they will grow from 0 to 24 hours. They will grow in terms of micron. Some don't grow, actually, quite big difference you can see there already. So now we keep looking for other reports. So we go here, you can see here is a multi-test of sphericity. This will give you a report about the homogeneity of variance. When you see here, the significance here is less than 0.05. So therefore we cannot use straight away sphericity. We have to use corrected value. Now we have to use a greenhouse instead of sphericity. This row we have to use a greenhouse Giza analysis, because this is corrected. The reason being because you have violated the homogeneity of variance, because p is less than 0.05. So we use this line. So with this report, it will tell you whether there is a time effect. See here, when you see this line here, this p-value is less than 0.05. Therefore, there is a time effect, and the longer you go, maybe the more effect you will see. From 0 to 24 hours, you have a number of the measurements in between. Now you see whether there is a time group effect. You see the same for you using greenhouse Giza value. Thus you have a significant effect. Therefore, this indicates that the effects is not only due to the duration, how long you treated, but also you have the group effect, meaning different concentrations of the compound. In this case, quinolinic acid you put in has the effect. If we put a high concentration and a low concentration, that will affect your neurite growth. So where can we see the group effect? Means the drug concentration effect. You see here is see the between subject effect. This is your group. If you see the p-value, here is p-value is less than 0.05. This is 0.044. Therefore, there is a group effect. So you need to report these findings. Finally, then you have a comparison. Remember, this is the repeated measures mainly give you a pairwise comparison in terms of time. So at the time for the group 1, for example, control group, you compare the time points at the different concentrations. They will only give you the time effects, but not give you a cross-sectional effect. So here I'll tell you exactly what does that mean. Here is give you more pairwise compare, give you a lot of data. Actually, in fact, in the reporting, you don't have to give all those numbers. It takes forever to read it. But the best way is to see a lot of time comparisons, because you have so many groups. Now, this is a good way to report. So this is a little picture to show you the time. 5 time points from 0, then you have 24 hours here, and then you have the middle measurement. Then you have 1, 2, 3, 4, 5, 6, 7 groups, and then you can match which group is which. This is actually the low concentration, the time effect. This is a high concentration. So this is your 0, then you will have a low 25 or 50. When it comes to the 25, then you can have high concentration. Then you actually you see the neurite growth is significantly reduced compared to the control group. So this gives you the whole two-way analysis, two-way repeated measure of ANOVA. Actually, give you the time effect, doesn't give you the cross section. For example, I want to compare at this particular time point, for example, 24 hours or 18 hours, for example, then it doesn't give you the effect. Compare this with this or this with this. In order to get this effect, then you have to do another analysis, which is a cross-sectional analysis. And this is surely has to be one-way ANOVA. Just one-way ANOVA. It's no repeated. Just one-way ANOVA. You can use one-way ANOVA to find the difference between these groups, all these groups, etc. So here's the summary. The function I have used. You can follow this function to select the specific function in the SPSS. Now here's the report. Maltese test of sphericity. You can see the p-value is here. So I can't use the first line. I have to use the second line for time effect and the time group combined effect. Then here is your group effect. So you have 3 findings: when the time and the group, or time and the group combined, and they are not separate. So this is a pairwise comparison. And pairwise comparison gives you a time effects, but doesn't give you the cross-section effect. See here, since we used a two-way repeated measure and ANOVA, this report gives the pairwise comparison between different time points. For group comparisons at various time points, for example, if we want to compare the 24 hours or 18 hours or other particular time points, a separate one-way ANOVA will be required. Here is your line plot.